I'm going to do a demonstration of hypothesis testing from Chapter 7, Section 1. The problem we'll read, and I'll try and hold it up here as best as I can for you. A local brewery claims that the mean or average amount of ounces in a bottle is 16. You do a sample of 64 bottles and get a mean of 15.9 ounces. From past experience, you know that the population standard deviation to be 2.3 ounces. Can you reject the claim that there is 16 ounces per bottle? Alright, so your first step is always to identify the claim. The claim will either go with the null hypothesis or the alternative hypothesis. It will go with the null, if it has some reference to equality. It will go to the alternative if it has a less than, a greater than, or a not equals. So that's very important to catch. So first again, it'll go with the null if it has some reference to equality. Greater than or equal to, less than or equal to, or just strictly equal to. It will go with the alternative if it's a less than, it's a greater than, or it's a not equals. In our statement, or the bottle, it says it is equal to 16 ounces. So if you look at our null and our alternative, right here, H sub 0 stands for the null, and H sub A stands for the alternative. The null will be the mean is equal to 16. That's our claim. And the alternative is that the mean is not equal to 16. Second thing we do is we state our level of significance. Now, an important piece here is that if no level of significance is given, we use the default level, and my hand's covering it, my apologies. We use the default level right here of alpha being equal to 0.05. The next thing is we determine if it's a two-tailed, a left-tailed, or a right-tailed test. We have, from the alternative, and it is always based off the alternative, we have a not equals, so it's going to be a two-tailed test. If it's a less than, it's a left-tailed test. If it's a greater than, it's a right-tailed test. In our tails, we write reject the null. In the middle, we write fail to reject the null. We need to find our critical values. Now our alpha is 0.05, and since we have a two-tailed test, we're going to split that in half, and we're going to have 0.025 for this tail and 0.025 for this tail. If it's a left tail or a right tail, you use the whole 0.05. I'm going to use INV norm 0.025, and I'm going to get negative 1.96. Now, the normal curve is symmetric, so negative 1.96 will be matched on the other side by a positive 1.96. Now we run our test statistic. Now there's two ways to do this. You can write it out by hand, and I don't require you to write it out by hand, but I want to show you what it looks like. So you're going to get a z-score. You're going to be running a z-test because you know the population standard deviation. Our z is going to be 15.9 minus 16. That's my son yawning, I apologize. 2.3 over the square root of 64. So that's our population standard deviation. That's our sample size. That's our sample mean, and that is the proposed population mean from the null and the alternative. I got negative 0.3478. If you did this on the calculator, the TI-84, you'll hit the stats key and you'll go to tests, and you're going to run a z-test, and you're going to see an input line, and you can either go to data or you can go to stats. Well, if you go to data, you'd be taking information off of L1 and L2, and you'd be typing data in and letting the calculator compute a bunch of stuff for you. We have the statistics, we have the mean, we have the standard deviation, etc. So we're going to highlight stats. The first line is mu sub naught. That stands for the mean from the null hypothesis. That's the 16. That matches that 16 that we got up here. The population standard deviation is next. We're going to list our 2.3. Our x bar from our sample is 15.9 and our sample size is 64. Now, which one of these three do we choose? This has to match our alternative hypothesis. So we will highlight the not equals. This should match our alternative hypothesis. When you look at your computer screen, that should be highlighted. And if I can get that back in there, the not equals should be highlighted. After that, go down and hit calculate. Now, I don't have my 84 at home with me, so I did this just by hand. So I got the negative 0.3478 right here. I got a thing called a p-value, which is about 0.72. Now I did this off Desmos, so it might have been a smidge different, but on your output screen you should have a negative 0.3478 and a p-value of about 0.72. Try and find those two values on your output screen. Now, if you look at negative 3.478 and you're looking at your distribution, that negative 3.478, here sits the 0. It's going to be to the left-hand side of the 0 because it's negative, and it's landing in the failed to reject region. But the other piece is that your p-value is larger than your alpha. That is also telling you to fail to reject. Those two things should always work in tandem. If they're fighting each other, the normal mistake is that you're looking at scientific notation. And so you need to adjust your p-value for scientific notation, and then they'll match up. So right now, what these two things are telling me to do is to fail to reject the null hypothesis. That means, I'm going to go back up, I'm going to circle the null hypothesis. That's what I'm keeping. That's good. That's what we want to operate under. So I now need to look at the claim. Is the claim in that box, or is the claim in the stuff that we're throwing away? So our next step is to say alpha is 0.05, but then if the claim is supported, we say there is sufficient evidence to support the claim, and then we restate the claim. If the claim was here, we would say there is insufficient evidence to support the claim. When I say here, I'm pointing to getting the line crossing it out. We'd say there's insufficient evidence to support the claim, and then we restate the claim. That's the pattern that we'll follow for hypothesis testing throughout the rest of the semester. The differences will be, we might have to change the parameter that we use in our null and our alternative. And there are a few different distributions we have to deal with, chi-square distribution, F distribution, and the test statistic might change. But other than that, that process that we just did follows through for the remainder of the semester whenever we're doing hypothesis testing. Hopefully that was helpful. Thank you.